We'll move to the last case study of the day. For that, I would like to invite Nitesh Patel from OpticView. He'll be going to present on case study on IoT and reality capture, showcasing how these technologies are applied in construction. Nitesh Patel is a structural dynamic expert with a rich background in designing and planning high-rise buildings and landmark projects. He's been with L&T, moved to Lera, and now is contributing through OpticView. Can we have a big round of applause for Nitesh Patel? Thank you. If you're okay with the cordless mic, then it's...
No, this is fine. This is fine. You can just give me. Yeah. Thank you, everyone. I'm Nitesh Patel, co-founder of OpticView Construction Monitoring Solutions. We develop different types of solutions for basically, monitor different types of construction activities, whether it's linear projects, infrastructure projects, or realty projects. So all our solutions are basically cloud-based solutions, and these are in and around reality capture field. So yes, being a structural engineer and working for 5 years in different construction companies, I know like what was the way 10 years back when we used to go to site, capture images, come back to office, create a presentations, and we used to submit weekly review meetings. Like, this is what has happened, sir, at this site, and this is what happened at so-and-so site. So it was basically a tedious process, right? And whatever the processes which we followed were applicable for small scale projects where you don't have huge teams, different teams involving in the projects. For that kind of thing, that was the best possible approach to document and report the projects. So yes, I'll come to our first product, which we developed based on the requirement we got from the construction sites. So the problem statement was, as a project manager or as a developer, the site team, the office team wanted to get the latest images or images from the site, basically. And all the projects, some of the projects which we were doing were basically on a remote locations, where the site team, where the office team cannot get, the video streaming or the images or what are the updates from the site to the office. So instead of getting, developing some video streaming for and with the limited resources available at the site, because we don't have broadband connections at most of the construction site, we developed a solution wherein we'll break up the live streaming part into simple cellular network system, wherein what we have done is every 10 minutes we'll be getting the images from the site, which will be captured by our camera, and it will be transferred to our cloud-based server using a cellular SIM card. And these cameras, once we install at certain height on nearby buildings, it keeps on running for years, basically. It's like autonomous system. You just insert the SIM card, all the images at every 10 minutes you're getting on the cloud platform, and that cloud platform can be accessed from anywhere around the world. So it was a very simple solution. Instead of getting low resolution video streaming, we converted that into a high resolution image-based system. Because see, the construction site, within 10 minutes, nothing much happens. Construction is slow progress. So if I get images, high definition images at every 10 minutes intervals of time, that's also more than enough. And second was that you cannot, if your project is like for years, like couple of years, 3 years, you cannot keep, you cannot store so much of video at some cloud platform. So if I have images or some visual data of any of your projects, all the images, I can store it for 5 years. We have projects which are going for 5 to 6 years, and you can access all the images from a single dashboard, basically. So yes, once I got the data set, images from the site, the next plan was to, process those images for different kind of things like PP hard hat detection, or what are the vehicular movements at the site. What are the different type of vehicles, construction vehicles available at the site. So what we did is we trained approximately 15 to 20,000 images at our end to detect different types of construction vehicles at site. For example, I wanted to see last week what was the maximum amount of, say, excavators which are at the site. From this dashboard, you can easily get it. Like what were the maximum number of excavators or maximum of dump trucks available at any particular time. Apart from that one, you can create the reports also. For example, like tomorrow, your concreting process is going to start, and you want to have a notification that when any concrete mixture enters the site, you get a notification. That can also be done here. And these are sample images which shows you like what are the different types of construction vehicles which we are able to track basically using image processing. Yeah, so I'll come to the next solution, which was like, for the safety hard hat and jacket detection, right? The existing solution was people were installing some video analytics cameras at the entrance of the construction site. But when we approached the team, the main problem was the workers who are entering the site, right, wearing jackets and helmet, that was okay. They are entering the sites wearing everything. After they reach the site, they removed everything. That was the main pain point which we thought of solving it, right? Because see, entering everyone definitely wears and goes. But what happens is after a couple of hours, they go to site, they remove jackets and helmets and everything. To approach that problem, what we did was, see, the construction sites are very huge. If you wanted to capture each and every small area, or if you wanted to have some analytics for each and every area for, hard hat detection, it is not possible. It is not economical. See, whenever we develop some solutions, developing a solution is a different thing. But actually to implement as a site and get money out of the client is again a different thing. So what we did was, we just installed a PTZ camera. And what we did was, for example, this is a whole site. And I've installed the camera there. We divided the site into small areas. You can see that black color areas, right? And what we did was, we programmed the system in such a way that every 10 minutes, whatever the area, suppose I have defined 30 areas, the camera will zoom into that particular area and it will capture the images at different zones. And whatever the images I get, we process it for hard hat and jacket detection. So that has, see here you can see. So for example, we have 25 location presets which we have divided the site into. We get the jacket and hard hat detection basically. This is how we have implemented there for the safety thing. Yeah, these are some of the sample images which we get from the site, wherein we are able to find out whether people who are wearing jackets and helmets, basically. Yeah, the second solution was, for example, that for the monitoring of exterior projects, right? You can install a couple of cameras outside of the building and you get to understand the overall understanding what is happening at the site. But the main challenges arise when interiors work start, like when the partition wall comes up, right? You cannot keep on adding manual cameras or going to site every time. So instead of that one, we came up, I'll just show you a couple of a slide which was shared to me with one of my clients. So this was how they were maintaining the photo documentation of their high-rise project. Like first they had floors, then areas, then dates, and they used to capture images. So instead of that one, what we came up was, these are called as 360 degree cameras, like Insta360 models. We have integrated our software with them. What we do is, the clients, for example, if they have high-rise buildings, they give us different layouts. You can see the layout. We mark a couple of important strategic points, and the camera is worn on the helmet by our team. We go to site, we stand at that location, we capture the image. And the same process is continued till your floor, like whatever 20, 25 points are completed. Once all the images are captured, you upload it, right? And this is how a normal 360-degree image will look like. Let me show. Can I play it? Yeah. Here you can see on the left side, you have a layout, a point, and here you can see a single 360-degree image is showing you everything regarding that site. And at the bottom line, you have the timeline. And here you can see, you can even compare here you can compare the progress of any site at any point at 2 different dates, basically. Okay? And apart from that one, we have integrated this dashboard with even the BIM model, wherein you can even compare as built versus what has happened at the site. And whatever the images which we are showing it to you, these are captured weekly once or 15 days once, depending on the client's requirement. Yeah, something like this. On the left side, you have a BIM model, which is a planned model. On the right side, you can have the latest image from the site, which the team captures and uploads, basically. So using this one, you can cover each and every dark point at any of your sites, basically. You can see it remotely. Yeah, apart from that one, we have an option to create a lot of snag lists, and everything is managed within the dashboard itself. Yeah, and I'm not going in detail, but you have this snag age analysis also, wherein you can track the snag list based on the type of issue or the segregation issue, like electrical issue or carpentry issue and everything. Now we have a drone. Is it completed? Okay, 1 minute. Yeah, I'll just go through what we have done in the drone. So whenever we meet clients, right, the main statement, they wanted a single vendor who can address all the reality capture-based things. So our main aim was to put in most of the problem statements or the solutions we get on a single platform, basically. And for the drones also, what we have done is, whatever the images or videos we capture, right, we are directly tagging it to the, all the images and videos are geo-referenced, basically. So if you have, for example, we were doing a bullet train project, they have a huge data set, like their data was approximately 40 dB, 40 terabytes of data. So every time, they cannot carry that much of hard disk through whatever, to the meetings wherever they go. We have here a cloud-based solution wherein you can upload all the data date-wise, and they can access it from anywhere. And all the images, videos, 360, this one, orthophoto are geo-referenced, basically. Yeah, this are, I'm just going fast. Yeah, these are orthophotos. Only last 1 minute, right? I have last 1 minute, right? Yeah, okay. I'll just, yeah, sure. So apart from that one, we are working on few of the things like scan to BIM and LiDAR photogrammetry. And this is our clientele list. Yeah, thank you.